laser line. Now we want to approach the sample. I should close this.
Yeah.
Show you.
How far are we from the sample?
Pretty far. So it looks like about a centimeter, a little less than a centimeter.
And do you mind if I ask, like, what is the Z height of the piezo?
The piezo is 12 microns. The
12 microns
stage
max.
has I think 1 centimeter about of maybe less. I'd have to look at the specs.
All right, but like the maximum height we can imagine is 12 divided by like 6 microns.
Yeah,
6
essentially,
microns.
yes. So what I like to do, you don't have to do this, you can even do it from a top view, is I use the side view.
Okay.
Especially if you have new students, this is probably the best way to start. So this is a 50 degree angle. We can zoom in to it to get a better view. And then we can scroll around a little bit. You can change the illumination if it's not bright enough. And we can also change the gain settings, and this should be on auto usually, so we can set these to auto. I should do the settings a little bit better. Okay, so first thing I'm going to do is bring the sample up so it's closer to the cantilever, and this is a coarse approach. I want to use these buttons here. So this controls the position of the stage.
So sample moves up here.
Yep.
All right, I see.
It's kind of in the opposite direction of what it's actually doing. So home actually lowers the sample to the lowest position. It just says home because it looks like the cantilever is moving up.
Mm-hmm.
Advance means I'm going to advance the stage toward the sample. So the arrow is like kind of in the opposite direction you're actually moving. It's just based on all our old systems had the motor in the stage, in the head. And
Yeah.
now this is the first system you have with in the stage. And so it's changes. I guess we could swap these around. But so I click and hold this button. Now you can hear the motor, right? So now this is bringing the stage up in toward the cantilever. And since I started at the lowest position, it's going to take a little bit of time.
How do you know when you're getting any closer?
You'll start to see some features appear here.
What if you don't have features like mica surface and you don't know exactly?
You can press approach and it'll do an automatic approach from any position. It just takes longer. So here
Oh, you
I can
see the tip reflection
yep,
too.
I see the tip. This is a piece of silicon essentially. So I see the tip here, and it's not a great view, but let's look at what the top view looks like. So here's a little bit better. I see the shadow behind it and the cantilever there.
And you can see some dirt on your surface too,
Yeah.
so that's...
So you can get to about this point. Let's see how far we are. Zoom in.
This is the danger of crashing the tip into the surface, right?
Yeah. So I'm pretty far away. Here's the cantilever, here's the shadow. Let me go even further.
You cannot adjust the speed that you're going towards.
Not on this. This always does full speed
Alright.
approach on the course approach. On the motorized approach, you can do.
Alright.
So this is a good place, I guess, to now do a motorized approach or the automatic approach.
So when you're close enough, that's when you make it
Yeah.
find the surface itself.
Yeah, and so here I click approach, and now what it'll do is a step by step. So it'll bring the stage up and then try to look for
Find
the
it,
surface.
yeah.
And this shouldn't take very much time at all. Yeah. So you get a little dialog says approach done. Just hit enter or press the OK button, and now we're ready to image.
So that's just bringing it to the surface. It doesn't start scanning, right?
Yeah, well we can't set it up to start scanning immediately after it approaches, but that's a extra setting.
Okay.
If I click on this arrow here, it opens up the advanced parameters in the approach menu, and here I can change how fast I do that final approach. Okay, so let's start scanning. I'll do a 25 micron image. So what's the first thing you notice?
Noise.
Noise, yeah. So this is telling me my gains are too high. And this is actually what I want to talk about with the gain settings. So what's happening is, so I set the imaging parameter. So image size, the time per line, points per line of resolution essentially, and then the rotation of the scanner. So 0 degrees means I'm moving perpendicular to the length of the cantilever. Then is the settings for the controller, and we have the set point, which is the amount of force I apply in contact mode.
Okay.
This is set to 20 nanonewtons, and then the 3 gains, PID gains. I is really the only one you normally have to change. You can adjust. So we usually do I and P, and I've never used D gain ever in my life. Okay, so.
I don't think the other instruments even have a DA.
Like Asylum Systems, you can get them, but you have to open up the advanced menu.
Yeah.
And Vico or Bruker, I'm not sure.
No, they don't.
Yeah.
I mean, I'm working.
Yeah.
Begin
and I gain.
Yeah.
All right.
So the set point here is the amount of force I'm applying, and that's assuming that you, it's using the value that you put in here for the cantilever, which is 0.2, and it's using a kind of a default setting for the deflection sensitivity.
Okay.
That might not be, those are 2 guesses, right? So 20 nanograms is a guess, but what we can do is actually set this to millivolts, which is the actual deflection signal. I think that's what Bruker systems do, right?
I don't do much contact mode, I have to be honest.
Okay,